Okay guys, just so everyone can kind of double check their diagram, I'm walking around and we'll have to review compass directions a little bit, just looking at a few of the diagrams, okay? And that's all right, we're just getting started. And to be perfectly honest, this is as tricky as a vector diagram will get, because this thing kind of backtracks on itself a bit, right? First it goes north of west, and then it goes south of east. Well, that's pretty much the opposite direction, okay? So let's just have a look at how we would draw this out. So our first vector, okay, is going to be 950 meters long, 30 degrees north of west. Okay, so I'm going to start here. I'm going to draw myself a reference line that's due west. Okay, and then I'm going to go 30 degrees north of that. All right, so I'm going to make that angle there 30 degrees. That's not bad for scale. Okay, my line's pretty crooked, but okay, 950 meters. Okay, there's the triangle for my first vector. This would be its x component, and this would be its y component. The reason I put this question on is to reinforce a couple of things I've been saying for like the last 3 days, and that is scale is important. Okay, if you throw off the scale on this diagram, it will lie to you. Okay, your math will be fine, and you'll disagree with your math. Okay, second vector is 385 meters. Is that a lot shorter than the first line? It's like about 1/3 as long as the first line, maybe a little more than 1/3. Okay, and it's 45 degrees south of east. Okay, so if I'm drawing an east reference line, it would look like that. Okay, now just from a little bit of kind of geometry, if this angle is 30 degrees, what would the angle be between these two lines?
30.
Also 30 degrees. So does that mean my line that I draw needs to be steeper than this line? It does. It's little things like that that can help me with the diagram so that I get the diagram right. So I want to draw a line that's about 1/3 as long as this, that is steeper than that one is. Okay? All right, and it's 45 degrees. That's not bad. That's about halfway between those two lines. Okay, for scale, that's not too bad. Okay, so that's 45 degrees. Okay, and it's 385 meters. I could have probably made it a little bit longer, okay, but it's still generally in the right direction, and it's generally the right length. Okay, so I'll have the x component for that one and the y component for that one. Last thing that needs to go on the diagram is the line that represents the total displacement of the combine. Okay, where do I draw that? Okay. Displacement is always from initial position to final position. Okay, this is my initial position. This is my final position because I drew the vectors tail to head. First I did the black one, then I did the green one. Okay, so purple line is my total displacement, and I've got its x and y components labeled there. Okay? Tricky diagram? Really tricky. Would it give you one like that on a test? No. Okay, to be perfectly honest, I would not give you one that involved on a unit exam. Maybe on a quiz, but not on a unit exam. Okay? On a unit exam, well, you know, I'll give you one after we do this one that would be more unit exam level. All right? This one I really wanted to illustrate how important your diagram is and how important scale is. All right, what's your next step after this? So I drew the diagram, I labeled all the x's and y's. I need to do something now with the x's and y's. What is it?
Find all of them.
Find all of them. Yeah, I need to calculate all the x's and y's. That's the trigonometry part. Okay, I'll give you a little bit of time to get that part done. All right, guys, let's look at the next few steps here. So for my black triangle, the 950 meter vector there, that's 30 degrees north of west. Okay, if I want to solve for black x, okay, black x is adjacent to the 30-degree angle, and I have the hypotenuse. So I'm going to take the cos of 30 degrees, and I'm going to multiply that by 950 meters, okay, to find out what black x comes out to. Okay, so cos of 30 times 950, and it gives me 822.72 meters west. Okay, for y, sine of 30, because it's the opposite side, times 950, that should be 475 meters north, if my mental math is correct. Sine of 30 times 950, yeah, 475. Okay, so that's meters, and that's north. All right, I've got to do the same thing with the green triangle. In the green triangle, I saved myself a little bit of time if I recognize something here. How can I save myself some time? Or at least one calculation.
So 45, 45, 90 triangles, the two sides are equal.
Right, it's a 45-degree angle, so the two sides have to be equal. They split the 90 right in half, right? So if you didn't notice that and did the calculation twice, that's okay, but you'll remember it next time I give you a 45-degree angle, which sometimes I do to try and save you a little bit of time. Okay, for x, cos of 45, okay, we'll figure out what it is, and then we'll just use that number again. So cos of 45 times, what was it? It was 385. All right, 272.24 meters, and that one is east. Okay, and then this one will be the same number because it's a 45-degree angle, so 272.24 meters, but this one will be south. Okay, so I found the x and y components of the two vectors I was given. What do I have to do with all the x's and y's now? Combine them. Okay, I need to figure out how far horizontally, in this case east or west, okay, that combine went. So I'm going to take the two x components and I'm going to combine them. I'm going to add them together. Okay, so purple x is going to be 822.72 meters west plus 272.24 meters east. But since this one is east, it's got to be negative because I made west positive in this one. All right. So when I do that calculation then, okay, so and I keep all of my decimals obviously. All right, so I take that number there and I'm just going to subtract that number there because adding a negative is the same thing. All right, so I get that the combine ends up 550.49 meters. West of its starting position. Right? Now I got to do the same thing with the y's. They are also both opposite. Okay, so I'm going to take the 475 meters north, and I'm going to add to that, okay, 272.24 meters south. Okay, so when I do that, so 475. Okay, minus the 272 gives me 202.76 meters north. Okay, you know what? My diagram didn't work out that badly. Okay, it's actually pretty close to scale. Okay, for a 550 meter line that is about 2.5 times as long as this one, okay, that worked out okay. Right? And if you're careful with your scale, it'll work out. You don't have to measure everything. Okay? All right, I now have the two sides of the triangle that includes my total displacement. How do I get the total displacement's magnitude? Pythagorean theorem. All right, so big D, okay, is going to be 550 with all the decimals squared plus 202 with all the decimals squared. I'm just shortcutting to save time on the board here. Okay, so I'm going to do that calculation in my calculator, but I'm not going to shortcut, and I'm actually going to use all of the numbers here. So there's the 202, there's the 550. Oh, but I forgot to put a plus in the middle. That's better. Okay, so I'm getting that the total displacement is 586.64 meters. Okay, that's the magnitude. What else do I need? I need the direction, so I've got to get theta. Okay, the way I drew this triangle, okay, theta is, 202 is opposite, 550 is adjacent. All right, so theta will be 10 to the minus 1 of 202 over 550. Okay, again, I'm going to keep all the decimals in my calculator so that I get the actual answer. All right, yeah, that looks like about a 20-degree angle on my diagram. So, okay, that agrees, 20.22 degrees. And which direction is that? North of west, yeah, okay. The angle arc is touching west, it's moving north of that, okay, so north of west. Now, if you got the complementary angle, okay, it would be 69.8 degrees, something like that, okay, that'll be west of north. Also fine if you just drew the triangle the other way, okay. All right, how many significant digits can my answer have? 2. The angles are measured values, okay? Like if I have an angle, that's something I measure, so it's a measured value, so those count. I use them in a calculation, they affect the accuracy of my final answer, okay? So my final answer has 2 significant digits, so that will mean then that my final answer will be 5.9 times 10 to the 2, right? Because I have to round off, I'm only keeping the 8, okay? That's as far as I'm keeping. That means I have to put it in scientific notation. Meters at 20 degrees north of west, or at 70 degrees west of north. Okay, either one of those would be acceptable. Arlen, question? Yeah, I know. I'm not quite done yet. Oh. Yeah. Thanks for reminding me. I skipped a step. All right, I missed a step. Okay, so the whole trip takes 540 seconds. What's the average velocity of the combine? So I actually shouldn't have rounded yet. I should have actually kept going with what I had there. Okay, so I've got to find the velocity. Overall velocity, is the vector the same? Yeah, all that work I did for the vector, that's right. I'm going to keep that. That's not going to change. Okay, displacement and velocity have the same vector. Okay, all I have to do is go v equals d over t as a final step. Okay, so that'll be the 586 number that we had divided by 540 seconds, right? It was 540 seconds, right? Yeah. Okay, so taking this number here, dividing that by 540 is gonna be like 1.1 meters per second at those lengths there. Okay? All right. That would be like the toughest question you could expect on even a quiz, okay? Unless I was to give you 3 vectors, but if I gave you 3, 1 or 2 of them would be like due east or due north, so you'd have less math.
If you mess up with like the significant digits in the test, is that marks off? Or?
Yes, yeah. If your answer doesn't have the right sig digs, the answer is wrong. Okay, so it is a mark for significant digits being correct. Okay. Here's the thing with significant digits. Like, this rule will work literally 99% of the time. I just do what I did here, right? Because I've got so many calculations, as long as I've used all of these numbers, whatever the lowest is, that's what I go with.
Isn't it 3 significant digits?
That's the highest. The 2 angles are only 2 significant digits. right?
Oh.
30 degrees north of west, that only has 2 significant digits, right? And they're measured values. An angle is something we measure, so they count. Okay,
Yeah.
is that clear? Yeah. All right, let me give you one that's more like what you would see on a unit exam. Okay, and I'm just going to add these vectors. I'm not going to make up a context, okay, for this one, like a combine or a giraffe or whatever it was I did yesterday. Okay, so. Okay, try that one. Give it a few minutes on the diagram, then I'll do the diagram. Okay, just looking at the diagram here, like I picked some numbers, and is scale important? Because it's close, right? And what I mean by close is, does it go below where it started, or does it stay above where it started with that 40-degree angle? Okay, so our first vector is 200 meters due north. Okay, so that would look like that. But our next vector is much longer. Okay, and it's angled 40 degrees south of west. So there's my reference line west. Okay, 40 degrees isn't quite halfway down. Okay, that one would be 350 meters. That angle there would be 40 degrees. Okay, so this will be Y, this will be X. Okay, I think it ends up slightly below or south of where it started. Okay, it's a tricky one, and that's why I picked those numbers. Okay, what if I wasn't sure? What if I drew this and I'm like, oh man, it's really close? What could I do before I finish the diagram?
Calculate y.
Yeah, I just go, okay, here's my diagram. I'm not sure if I should end up below where that started or above where I started. Okay, I mean, I think my 350 is pretty good, but who knows about the angle? It's about 40. So I'll just calculate y, and then I'll know. Okay, if y is bigger than 200, then it goes below. If it's less than 200, then it stays above. Okay, you can always kind of double check your diagram, and usually if I give you one that's due something and then one that's angled, it's going to have that come into play a little bit so that I'm checking the scale of your diagram. All right, let's give you a few more minutes on that one, guys. All right, so what I didn't do with this diagram is I didn't draw the resultant on here, did I? Okay, like I didn't draw a line representing the object's total displacement at the end of this. Okay, that line would go from here, the initial position, to there, the final position. And that would make a triangle like that. It's going to be super thin. Okay? Now, why does it look that way? It looks that way because one of the vectors is only north. And the other vector goes south just a tiny bit further than that first vector went north. Okay? So I only end up like 24 meters or something south of where I started, but I end up a long ways west. Okay? Because in that second vector, we go west a long way, like 287 meters or something like that. Okay? So this is my resultant here. Okay? It has an x component and this very, very small y component over here, and it has this very, very small angle, and then of course its magnitude, how big it is. right? We're still following all the same steps here, guys, as we did with the far more complex question we did just before this one, right? If I'm looking at my purple vector here, I just go straight north. So how far do I go horizontally if I go due north? I go 200 meters north, yeah, that's my y component, but my x component is 0. If you go due north, you don't go east or west. X measures east and west. Okay? This line, because it's straight north, doesn't make a triangle. Right? It's just a vertical line. Then, for the green triangle, I just do what I always do. I find x, it's the adjacent side. I find y, it's the opposite side. Okay, so x, green x will be the cos of 40 degrees times 350. Okay, so that's 268 meters. I'm keeping all the decimals in the calculator. Okay, and then for y, it's going to be the sine of 40 times 350. All right, so that's going to be 224. Okay, so in this second vector, we go 268 meters west, and we go 224 meters south. Okay, we went 200 meters north in the first part, and then in the second one, we go just a hair past that, okay, in terms of going south. But we end up 268 meters west. Okay, so now I've done all the x's and all the y's. It was way less work for this one because I didn't have to do any trigonometry for the purple vector. It wasn't a triangle. It was just a vertical line. Okay. All right, can I find red x right now? Or did I already find it? I already found it, okay? Because the only time I go west in this whole question is right here, okay? That's all the east-west in this whole question because purple x is 0. I'm still doing the same thing I did on the last question. I'm taking the two x's and I'm adding them together. It's just easier because one of them is 0. Okay, so red x is going to be 268 meters. Okay, and red y, that's going to be the 200 minus the 224. I'll actually put in the numbers here. Just so I have all the decimals. Okay. 24.98. Okay, do I have the two sides of my total displacement now? Can I do Pythagorean theorem and find out what my total displacement is? Okay, it's going to be like 270 meters maybe. Okay, it's not going to be very much. It's not very much bigger than this number because it's a very, very thin triangle. All right, so that number there squared plus that number there squared. Yeah, 269.228. Okay, can I find the angle? And do the same thing I did on the last question. I am. I still have the two sides of the triangle here. Okay, so this little theta right here, okay, I'm still going to go 10 to the minus 1 of the opposite side, 24.98, divided by the adjacent side, 268.11 or whatever it was. All right, that's a small angle, right? It's only 5 degrees, okay? So 5.3 degrees south of so my final answer will have two significant digits, because that 40-degree angle only had two significant digits. So my final answer will be 25 meters at 5.3 degrees south of west, or 85 degrees north, west of south. Okay? If I drew the triangle the other way. Right? If I drew the triangle like this, I'd be finding that giant angle, and it would be 85 degrees. Okay, and it would be west of south. All right, now, I think that one threw you because I didn't draw that last displacement in there because I was trying to see if you guys would do it. All right, I'm going to make up another one just like this, but I'm going to give you a 5-minute break to rest your brain because I feel like right now you guys are a little shell-shocked. Okay?
Do you know what the displacement for this was?
Yeah.
And then 269. Yeah. So if you're writing precision, I think the significant digits are confusing me. So, because the small significant digit there would be 2, right?
Yes, because of the 40.
Yeah.
Ken, did I say the displacement was 25 meters? I just heard this, I heard myself talking in my head, and I'm like, what? Wait a minute, that's what confused you. Yeah, sorry, the total displacement should be 2.7 times 10 to the 2 meters, not 25 meters. 2.7 times 10 to the 2 meters, okay, at 5.3 degrees south of west. You know, sometimes you hear yourself in your head after you said something, wait a minute, that wasn't right. I just had that moment. But nobody said anything either. That's like, you guys look really shell-shocked. It was because I misspoke. Okay, does that make more sense now?
Yeah.
Okay. All right, I'm still going to give you guys 5 minutes, even though it was my mistake. Okay, and while I'm giving you that 5 minutes, I'm going to make up another one here. Okay, so we got 27.5 meters at 35 degrees north of west. Okay, so I'm going to go, here's due west. I'm going to go 35 degrees north of that. Okay, and then my second vector is 22 meters due south. So that's definitely going to go past where I started. Agreed? Right, if this one's 27.5, this side is definitely not 22. Okay, so it's definitely going to go like this. Okay, maybe to about there. Okay, and we'll say that that's 22 meters there. That will put my overall displacement as a line that looks like that. Okay, and then you can draw the triangle either way. You can draw it here or inside the diagram, makes no difference. Okay, so we'll have y, x, x, and y. All right, so we got to first find our x's and y's, right? That's the second step after drawing the diagram. Okay, so in this one here, x is the adjacent side, so I'm going to go cos, whoop, red. Okay, cos of 35 times 27.5 meters. Okay, so cos of 35 times 27.5. Whoa. Cos of 35. Okay, it gives me 22.53 meters west. Okay, and then y is the opposite side, so that'll be the sine of 35 times 27.5. Okay, that's going to be 15.77 meters, and that is north. Okay, everyone all right with the first one? Okay, now for my blue line, it's due south. What is its x component? How far does the blue line go east or west? 0. Yeah. Okay, if you have a vertical or horizontal line, they only travel in one dimension, either the x if it's horizontal or the y if it's vertical. All right, and that means that the y is 22 meters south. Okay, I don't have to do any trig because there's no triangle. All right, everyone with me so far? Okay, so if I want to find black x and black y, finding black x is pretty easy. I only go west during the red vector. So however far west the red vector goes, that's how far west we went, ever. Okay, so I'm just going to take that 22.53 and write it right here. Then I'm going to go plus 0 because, well, the other one was 0. Okay, so this is 22.53. Okay, and then for the y, okay, well that one I actually do have two values. One is north, one is south. The south is bigger. Okay, so I'm going to take the south and subtract the north, so I get this remaining y right here. If you drew the triangle the other way, you're going to get the same numbers. You just have it, the triangle the other way. Okay, so y is going to be 22 meters south minus 15.77 meters north. So take that 22 there and subtract that number right there. Oops. Oh, no, sorry, not that number. Oh, sorry guys, I messed that up. I just need 22, not that number. 22 minus that number. Okay, so I get 6.23 meters south. All right, I now know x and y for my resultant's triangle. Can I do Pythagoras now? Okay, that's my next step. Okay, that will get me the overall displacement there. Okay, so that will be the square root of 6.23 squared plus 22.53 squared. Of course, I'll keep all the decimals in the calculator. Okay, so 23.37 is the magnitude of my total displacement. Okay, and if I want to find the angle, the way I drew the angle, x is opposite, y is adjacent. If you drew it the other way, that's fine. It's just going to be reversed. Okay, so I'm going to have 22.53 divided by 6.23, again with all the decimals. Okay, so I'm getting a 15.45 degree angle that is west, oh sorry, I did that the wrong way.
Yeah.
I went the other way. Sorry, let me try that again. I did it the way you guys probably drew it, not the way I drew it. That's not 15 degrees. It's 75 degrees. 74.55. 74.55 degrees west of south. Okay, how many significant digits should my final answer have? 2. Okay, I have the 27.5, that's got 3. But the 35 has 2. And I use the 35 to calculate my final answer, so 2 is the number. Okay, so my final answer would be that D is 23 meters at 75 degrees west of south, or at 15 degrees south of west. Okay? Everybody all right with that? Okay. On every single one of these questions, have we done the same steps? Right? We draw the diagram. We identify the x's and y's. We calculate the x's and y's. We add the x's together. We add the y's together. We do Pythagorean theorem. We do trigonometry to get the angle. We do significant digits to get the answer. We're done. Every single one has worked the same way. And they will all work the same way. Okay? As long as you follow those steps, okay, and do a decent job with your scale. Okay? My scale was okay there. Okay? The angle might have been a little off, but it wasn't bad. My diagram didn't lie to me, at least. Okay? All right. In the workbook, if you have it printed, if you don't, okay, there's a bunch of vector addition questions. And they start out super easy. Like in question number 1, you've got like 2 that are collinear, then you got 3, actually, and then the rest are like perpendicular. Okay, you can still draw them tail to head, you still do all that stuff. Okay, but those are kind of way past what we're already, or way in the past from what we're doing. And then that's just finding components. Let's have you guys try 3C. It's very much like the ones we just did. Okay, let's try 3C. Okay guys, just so you can double check your diagram here. Okay, you got 8 meters east. And then you've got 6 meters at 35 degrees north of east. So reference lines still due east. Okay, 35 degrees north of east. Or 6 meters. Okay, should look something like that, okay, with this being the total displacement. Okay, those practice quizzes, if you go into the class and then you go into class work, okay, they are right here, practice quizzes and solutions, go to Kinematics, okay, and you will see all those quizzes in there. So if you just go like view material, okay, quiz 7A is here, quiz 8 is there, and if you click on this right here, that will take you to the YouTube playlist that has the solutions videos. So if you scroll down, okay, oh, I don't have one for 7A, just do 8, okay? Actually, you could probably do 7. I think 7 and 7A are the same quiz. Okay, so you can check those ones out there. It's just the solutions. Scrub to the end to find out what the answer is. If you don't get it, watch the solution. Okay, that would be my recommendation over the next couple of days to pick away at. Okay.